Okay, Assalamualaikum warahmatullahi. My name is Luqman. I'm from 5XPM3. I'm 8. Okay, today I will explain about the what are stress and what are strain. Okay, now we go to the next slide. Okay, now we know the definition of stress and strain. Stress and strain are the two terms in physics that describe the force causing the deformation object. Next, deformation is known as the change of the shape of an object by application of force. The third one is very small force can also cause deformation. And the last one, the object experiences it due to external force. For example, the force might be like squeezing, squishing, twisting, tearing, ripping, pulling the object parts. Okay, now we go to what is stress. Okay, what is stress? Stress is the force applied per unit area in mechanics is known as stress. The following formula represent it. Okay, as you can see, the formula for stress is sigma equal to force per cross-sectional area, or in easiest way to remember the formula is sigma equal to F over A. Okay, next, sigma is stress applied, F is a force applied, and A is the area force applied. Stress is measured by unit m/meter square. The ratio of the internal force produced when a substance is deformed to the area where force is applied is known as stress. At equilibrium, the internal force is equal to the magnitude of externally applied force. Okay, next we go to what is strain. Okay, strain is a ratio of the amount of deformation experienced by the body in the direction of force applied, the initial size of the body. The relation of the in terms of length of the solid given below. Okay, as you can see the bottom, the diagram is strain and the formula. Formula for strain is epsilon equal to the change in length and the original length L. Okay, epsilon is a strain to the due stress applied. SL is a change in length, and L is the original length of the material. Strain is the ratio for change of shape or size to the original shape or size. It is expressed in number as it doesn't have any dimension. Okay, we finish about stress and strain. We go now the difference between the stress and strains. As you can see now, this is a difference between stress and strain. The first point is stress is a restoring or deforming force per unit area, while main strain is the change in shape per original shape. The second point is the unit for stress is N per meter square, but strain is a unitless quantity. The third point is stress can exist without strain, but strain cannot exist without stress. And the last point for the differences between the stress and strain is the various type of stress is tensile, compressive, and shear stress. But the various type of the strain, tensile, compressive, shear, and volumetric strain. Strain got extra one, the various type. Alright, that's all from me. Thank you. I will pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Qais Razali. So I'm the next presenter. I will continue what have been covered by Luqman Hakimi about stress and strain. So I will cover about stress and strain under three different of conditions. So the first one is axial. So when stress and strain under the axial loading is determined that axial loading is defined as applying a force on a structure directly along an axis of the structure is mean if we have one object, so the force will react in this direction or this direction. So it's what is mean by axial loading. Next, I will cover about torsion. So what mean by torsion, or we know about twist, is when torque is applied to a shaft cause a distribution of stress over the shaft cross sectional area, and then shear stress depend on the applied torque. The difference along the radius of the shaft and the polar moment of inertia. So it's mean by torsion, like if we want a shaft and then we twist it in a different direction like this, so in this sectional area it will have a stress, so we will calculate the stress in this area. So the third one, I will talking about the bending. What is the stress and strain defined in bending? It is prismatic member subjected to equal and opposite couple acting in the same longitudinal plane. It means if we have a beam, so the direction of bending is like this, so it means is the bending value is equal, but and it is opposite couple. It means this go this direction, and this end also will go the same direction as this end. Alright, and then the stress and strain are negative if it compressive above the natural plane. It mean like this, which mean it's like a set like our mouse, it will be bend like this. It mean negative. And then it will positive when tension below it. It mean when we smile, it mean it is positive. Alright, next I will cover about the equation for axial. As you can see here, we have how to determine it. It is strain equal to elongation over length. So first we see the rod before we apply an axial loading. So the second picture, we can see the transformation after we apply the axial loading. So it has some elongation at the second rod. Next is I will cover about the equation of torsion. So the equation of torsion is angle of torsion equal to radius times theta and then over length. So as you can see in the picture, we have the angle of torsion, and then it's also be given the radius and then the theta and the length, so we can calculate it to get the torque. And the last one is equation for bending. So equation of bending, we have bending stress equal to calculate bending, and then times vertical distance away from the natural axis over I is mean moment of inertia around the natural axis. So that's all from me. I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Megat Izzuddin bin Megat Shahriman, and I will continue to explain about the next part, that is transformation of stress. Okay, what is transformation of stress? Okay, firstly, before we understand stress transformation, we need to understand the stress element. Okay, here is the stress element diagram, and to further my explanation, I will explain about the 2D element or plane stress to explain about the stress transformation. Okay, stress element is a useful way of describing the stresses acting at a single point within a body. Okay, normal stresses and shear stresses are shown like in the diagram on the four faces of the element. Okay, we move on to the next slide. There is using an example of a beam under axial load. Okay, that same stress element as earlier is put in a same direction with the applied load. So the stress state is very simple. It is become like this. Okay, so there will only be a normal stress or sigma x, and the shear stresses will be 0 or sigma y equal to 0. Okay, we move on to the next slide. What happens when the stress element is rotated? Okay, the stress element could be rotated to get the stress state for a specific angle. So, depending on the orientation of the stress element, we will get different values for the normal and shear stress component. Okay, to answer the earlier question of what is transformation of stress, when we rotate the stress element, there will be angle involved. So any calculation will be using the stress transformation equation. So we move on to the next slide. Okay, this slide is about the stress transformation equation. Because as we rotate the stress element, we can calculate the normal and shear stresses by using the stress transformation equation as provided in this slide. Okay, the input to this equation that I provided in this slide is the normal and shear stresses at the starting orientation before the rotation of our stress element. For this equation, theta is the angle through which we are rotating the element, and theta also is positive for counterclockwise rotation and vice versa. Okay, we move on to the last slide. Okay, I would like to briefly explain about Mohr circle and its relationship with the transformation of stress. Okay, Mohr circle is an alternative method that can be used instead of the equation earlier. Mohr circle use a graphical method, a circle that involves creating a graph with sigma as your abscissa and tau as your ordinate and plotting the given stress state. Okay, that's all from me. I will pass to the next presenter. Assalamualaikum and thank you.
Next, my point is about what is Mohr's circle. So Mohr's circle is two-dimensional graphical representation of the transformation law. So it is used to calculate material strength, stresses in planes which reducing to vertical and horizontal components. So it is visualized the relationship between normal and shear stresses acting on a stress element at any desired orientation. It is determine normal and shear stress without using the stress transformation equation. Next is how Mohr's circle constructed. So firstly, draw horizontal and vertical axis. Next, normal stress horizontal axis, while the shear stress at the vertical axis. Plot the stress corresponding to the x phase, that the stress element with coordinates of sigma x and tau xy. Plot the corresponding point of stress on the y phase with coordinates of sigma y and tau xy. Sign convention for the Mohr circle is shear stresses is positive if they tend to rotate the stress element counterclockwise and vice versa. Normal stress are positive if they are tensile and negative when they are compressive. Then the line between 2 points represent the diameter of Mohr circle. So when the blue line on the pages right now, when the blue line, which is the diameter of the circle, has been constructed, then draw the whole circle of the Mohr circle. Then the maximum shear stress is equal to the radius of the circle by measuring the distance on paper or using the equation of the circle. The principal stresses determined by looking at the circle cross the horizontal axis as the shear stress is equal to 0. So the principal stresses is equal to x coordinate of the center circle by adding or subtract the circle radius. Then the angles of Mohr circle can be calculated using trigonometry. Calculate the angle theta b between original stress element and principal planes. And the angles in Mohr circle is doubled compared to the rotating stress angle.